Alright, hello YouTube. I just wanted to do a quick video on some pretty cool motors that I just got. And what's great about this is these things are used every day in HVAC applications, and they may not look like it. They look like your typical blower motor. As you can see here, it even says that it's like 1 horsepower. Or this one says like it's a half a horsepower, and this one says it's a half a horsepower, and this one says it's 1 horsepower. But that is a gosh darn lie. What it is they're rating the controller that they put on the back of these things. And the interesting thing is these controllers, if you look online on eBay or whatnot, here, let me find them. If you look on eBay or whatever, these controllers are about $600. And I'm going to tell you where I got these, and I didn't spend over $20 on all these motors. And there's a controller here. Here, let me get another controller here. Here's another controller here. And the only thing that goes bad, this one actually is really good. There's nothing wrong with it. These are brushless DC 3-phase motor controllers. They're built on to the back of these motors like this. So when you look at this motor, it doesn't look like a 3-phase motor. But it is. And see where I get, here, I'm going to put you up here real quick. Make sure, I don't know if it's going to be, oh, sorry about that. Let me make sure. Okay. Alright. So, these are 3-phase motors. Where I got these motors is I go to my local scrap yard. And I got a buddy up there, well, I made him my buddy, and people scrap these motors all the time. HVAC workers, installers, or whatever, they go, and the problems is these controllers have one little thing go bad on them. They're very common for doing this. A lot of times it'll be this guy, that little thing will burn up, which I have a controller right here where that's exactly what happened. If you look right here, you can see where that got burnt. And basically all I have to do is put one of those back, which is one of these discs. And if I put one of those back in right there, this controller will work fine. This one, you can actually use a potentiometer to control the speed. Now the rating on these, as far as a half horsepower, I believe is a crock of BS. I don't think that they are limited to that, because I have a Anaheim controller just like the one Gerard Moore uses for brushless DC motors. You have to have Hall sensors, but that motor, or that controller, when I put it on one of these motors, this thing spins to about 4,000 to 5,000 RPMs. Ridiculously powerful motors. These are very, very, very powerful motors. And they're right underneath our noses. A lot of people do not even know what they're scrapping. The HVAC installers, the maintenance technicians, they don't even know what they're taking to the scrapyard when they're going to scrap these motors after they replace them, because the controller will go bad on them. So they just buy a new motor. A whole entire new motor is about $800. Listen, this is $800 for one of these motors, because they're paying for the controller and the fact that this is a 3-phase permanent magnet brushless DC motor. They're in your air conditioners. They're controlling the fans and their variable speed to make their HVAC units more efficient. They're called, a lot of them are called ECM motors. So if you see one of these ECM motors, now I've got a controller, or one of these motors right here that says ECM on it. Here's one right here. And I got these two standing up to show you. You can see the permanent magnets in there and all the coils around it. These are 3 wires coming out on all of these. These are 3-phase motors. And I just thought that was fascinating, and see, use only with correct control is what they put on there, because you can't just hook it up to power with a capacitor like typical blower motors. You have to have the controller. And you can see these holes here. I took the controllers off the back. It bolts right onto the back of this and completely hides it in plain sight, because they have built-in controllers on them. This right here, I don't know if you can see this, but it says right there, it says ECM. And if you look at some of my past videos on a water wheel that I made, in the creek. Basically, I have an ECM 3.0 motor, which is a big 1 horsepower. That's this motor right here. I had it in the creek. This is a ECM 3.0. You can't read it anymore. But I had this in the creek with a small water wheel with a 3-phase bridge rectifier. So it takes 3-phase AC and turns it into DC. And just at very low RPMs, I was able to get 18 to 20 volts DC out of this thing at I think it was 4 to 5 amps. So that, I mean, that'll charge a battery really well at low RPMs. So all of these motors, I'll tell you where I got all these, and the controllers. I got another controller right here. And they all have one simple thing that's wrong with them. One simple thing. This is a, see right here, it got hot right here. Like all I have to do is resolder that spot because it got hot. And that's on one of these. You can see it's got the bridge rectifier right here. It converts the AC to DC with the capacitors, and then down here is the controller that controls the 3 phases and pulses the power. This is where your 3-phase motor hooks up to. This is a very, very expensive controller. If you were to outright buy one of these brand new, you're looking at $600 or more. Guys, I got all of these except this one I already had. I've got all of this right here. All of this. I went to my local scrapyard and I gave them $17. $17, and I got all of this. These are all generators. Don't have to do anything to them. If you look at my other videos, you see I make generators out of ceiling fans. I make them out of induction motors. I made them out of everything. But when I discovered these motors, and now that I managed to find a bunch of them at the scrapyard at one time, I bought this one at the scrapyard for $6 by itself. I did not even know that it was a 3-phase brushless DC motor. I just know when I turned the shaft that it felt a little funny, almost like it had magnets in it. So I was curious, and I didn't want to spend a bunch of time in there and make it obvious what I was doing. But now they know I make windmills and they know what I'm doing. So when I go in there, they're really cool, and they're like, "Yeah, man, go ahead and check our pile, whatever you want to look at." You know, and they had already dumped them into the big dumpster, and they actually let me go over there and dig through it, and that's where I found all of these. So I was able to look around and dig through their big pile. And I was able to, you can spin these when you're going to find these, you can spin this and you can feel the magnets in it. Another big way to find them is the controller will be built into the back. So it'll be, a lot of times they have the holes in it like this for getting air too. So the controller will be mounted on the back like this. So you'll see the motor, and typically these blower fan motors are small like this, but you'll see the motor, but then if you look on the back, you'll see this box on the back. That's how you know those are the ECM motors. Those are the ones that you want. And you can go to your scrapyard. I guarantee you they'll have them, because these things are getting scrapped left and right, and nobody even knows what they're doing. A lot of these guys don't even realize what they're scrapping. So I just wanted to put a quick video out there to show you how easy it is to get your own generator for anything you want to use it for. I mean, I spun one of these up with a regular induction motor, single-phase induction motor, and they put out a lot of power, man. They put out a lot of power. I couldn't imagine if you were to take the core out and put neodymiums on there, how much power you would get out of these things. But I'm still got a lot of experimenting to do with these. But I was super stoked because I went to the scrapyard and I literally hit the jackpot. I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 of them still had the controllers on them, but 2 of them did not have the controller on them. The controller was already gone or broke off. I mean, they just dumped them in there, and one of the controllers got beat up, you know, like they don't even realize what they're doing. But you can look these motors up for yourself, and just if you want to turn a profit on these things, just to go to the scrapyard, just to get them, you can go buy these from the scrapyard for, I'm telling you seriously, I paid $17 for all this. This controller's over $500. This controller's over $500. This controller's over $500. And this controller's over $500. Altogether, with the motor and controller, you're looking at like $890 something is what I saw on eBay for one of these complete sets. So we're talking about 800, 800, 800, 800, and the motor without the controller, I don't even think you can buy. You can buy the controller by itself, but I don't think you can buy the motor without the controller. So we're looking at another 800, 800, 8, 16, 24, 8, 16, 20. That's $4,800 in motors that I just got for $17. They already generate power without having to do anything to them. Literally, you hook it up to a rectifier, spin it up, and bam, you have a generator. And I just thought that, you know, people might like to know this. Go by your local scrapyard, see what they got. The windings in here, are pretty thick. It's much thicker than a ceiling fan, and I get, you know, some good voltage out of those. But the wires in here are thick. I mean, these are awesome, awesome, awesome generators. People are making these from scratch and spending all this time to make, but yet they're right here. And look how easy this spins. Literally, I'm barely turning it. You can feel the magnets in there, but they are virtually, I mean, they don't hardly cog at all. You can see it's cogging just a little bit. You can see it jumping. But, I mean, this thing is really easy to turn. Watch this. That's generating a lot of power right there, just like that. And it's really easy to turn. So you can use these to make, you know, using alternative energy, you know, you can use water, or you can use wind, or whatever you want to use. These things will turn very easily, and they will put out a lot of power. And they're already done. See, this one, the magnets are really strong in it. I haven't opened it up yet, but I'm pretty sure this one has neodymium magnets in it, because you can feel the cogging is much stronger, and in just the way that it sucks it to the coils. It almost feels like there are definitely neodymiums in here. I'm almost certain of it. And this one is not a GE. A lot of these are Gentech motors. You can see right here. I'm going to go ahead and show you the whole label on this. Hopefully you can see this. This is a Gentech EON, not an ECM. This is an EON, rated for a 1/2 horsepower. And see, this is what's curious, is they say 120, 240 volts. Amps, no number. RPM, no number. They don't even tell you, because they're variable speed. And the controllers on the back control the speed. And somehow the unit communicates with the controller to control the speed of these motors. But they should not have a horsepower rating on these motors, because I think that is a lie. There's no way one of this size is just a 1/2 horsepower, because when I spin this up with my Anaheim controller, it is powerful. I mean, it spins up fast. I have to get my Hall sensors in there just right, but once I got them placed, I mean, this thing goes, I mean, it spins like crazy. So you cannot tell me that that's only a 1/2 horsepower, because it's a 3-phase motor. When you put power to this thing, it's going to turn. No matter what you do, it's going to turn. You know what I mean? They're so strong, and they're big brushless DC motors, and you can get them cheap. So cheap. I can't believe that I got these. And I'm going to be going back to my scrapyard, and I'm going to be doing this over and over and over again. And I'm going to see how many of these things that I can round up in a short period of time. Because literally, if I would have kept looking, there was probably 10 more. And all that they charge me is they put it right back on the scale, as if they were giving somebody scrap money for them. So these people are giving up these crazy expensive motors, and they got $17 for it. You know what I mean? So they put it right back on the scale, and they tell me how much the weight is, and all I have to do is have cash. As long as I got cash, they take the cash, they put it right in their pockets, and I walk away a happy man. So it's that easy. You just gotta, you know, go in the scrapyard, approach them correctly, talk to the right people, and you can do this. And you can do this very easily. So I want to do a quick, short video to explain these motors and how you can get them cheap. And I wanted to show the insides of them, to show what they are. And man, these things are awesome. I'm so excited to play with these more. I'm gonna do a video where I hook up my Anaheim controller to one of these, and I'll show you how these things spin up. Right now I have to go to work, so I can't, but I'll show you how these things spin up. And I'm gonna be repairing all of these controllers. So I'm gonna be repairing this one. I don't think is anything wrong. It's even got a light in there, so it'll show you the pulses of the power, I think, or I don't know. I'm gonna have to look into it more. But this one is, I have to figure out the wiring. If anybody knows anything about these motors, and they can tell me the configuration of the wiring, because I'm having a hard time. No matter everything you look online, there's no diagram for the pinouts or the wires. It's like almost like it's a secret. I can't get any information on how to wire these. Some of them are more easier than others. Like this one is just got 3 wires. There's your power in. Bam, there's your power out. As far as the controller, I've only got 4 wires. I can figure out how to put a potentiometer in there and control the speed. So this one I'm pretty excited about. It's really cool, really freaking cool. But and you can see all the switching transistors in there. I mean, I'm pretty sure that's what those are. And it's just, these are nice controllers. That's why these motors cost so much. My Anaheim controller was $100 and something, $180, and you know, it spins up these motors ridiculously fast, way higher than what the RPM rating is on these things. There's a few of them that do have an RPM rating, but back to the point. I'm going to be fixing all of these and making them work and putting potentiometers on them. And this one is for 1 horsepower. It's got all 4 capacitors. You can see these other ones, they've got 2. This one's got 2, and you know, this one's got 2, but this one's got 4 big capacitors. So I'm pretty excited about this one. I'm pretty sure this one's going to have some good output power. But what these controllers do is they don't use a lot of amps. So you can look on here and see the amperage rating for this motor is ridiculous. They don't even put one on here. On this one, they don't even put one on here. But let's see this one. 1 horsepower, 120, 240 volt, which that's to the controller. What goes to the motor is not that. The controller has an output. When it converts it to DC, it says 310 volts DC. 310 volts of DC goes to this board in the back. So this converts it to DC right here. You can see the big rectifier. And then from here to there, you've got 310 volts DC going to this part. And then the output here. This one has programming wires here, which I'm really wanting. This is a train programmable motor wired for 7 amps. 7 amps. So this thing uses 200 to 230 volts. What uses 200 volts anyway? Why would they have 200 volts on there? Nothing is 200 volts. This is just very strange. So it's a variable voltage. The voltage don't have to be perfect to run these things, but just like my Anaheim controller, it's got a 7 amp fuse in it. 7 amps. You got these guys building these electric skateboards and everything, and their motors, their controllers, they're rated for 80 amps. 80 amps to power this little bitty motor. You know what I mean? Because they're running at low voltage, high amperage. These controllers don't do that. These controllers do it at high voltage, low amperage. That is the key. That's what Gerard Moore was trying to tell us, but they're doing it right in front of our faces. It's right here. This thing right here can run this motor at way more than the 1 horsepower or half horsepower rating. That's a joke. That's not true. But it's running these motors on high voltage, low amperage. This is what I've been looking for. So when I build my electric scooter or whatever, and it's only going to be drawing 7 amps, you know, because I'm just going to use a battery with an inverter to get the 120 to 240 volts that I need to power the controller, and then I'm only drawing 7 amps. 7 amps instead of the ridiculous amperage that you know, typically the brushless motors on scooters and stuff use. This will be using much less if it works like I think it's going to work, and that's what I'm thinking is going to happen. So I mean, I've got 2 brushless motor controllers that are rated for 80 amps, and I don't understand why the amperage is so high on them, but I figure it's because they're using low voltage. I do have one that's rated for 60 volts, and I'm pretty excited to try that one. But I'm thinking the way I'm going to go is I can mount one of these on this motor, and I'm going to do another one right beside it with a controller on it. So I'll have 2 of the same size motor. We'll use these 2, for example. So I'm going to do 2 like this, And this is going to be the rear end of my trike. I'm going to build a trike with a rear end like this, and it's going to have individual motors on the rear end. And set up a controller that'll run 2 motors. And if I'm right, I'm going to have a battery and an inverter, and the inverter is going to power the controllers. And I should be very, very efficient with a lot of power to make one hell of a scooter. And that's what my goal is. And not only that, obviously they're generators too, but I'm curious to see how efficient that we can use these motors on battery operated devices like scooters or skateboards or whatever. You know, can I use an inverter? I have a 1,000 watt inverter. 120 volts at 7 amps is less than 1,000 watts. So at max output, 120 volts at 7 amps, my 1,000 watt inverter theoretically should be able to run, you know, the motors, no problem. And instead of using 80 amps from the battery, I'll be using 7 amps from the battery. You know, but obviously once you drop that down, that's a good point. Once you drop the voltage down, so we'll be drawing 12 volts, so the amperage obviously will go up for what you're pulling from your battery. So if we do 120 volts at 7 amps, divide 120 volts by 12, and then, you know, whatever that is, you multiply that times 7. I mean, it's going to be a lot of amps coming from the battery still, but I still think it's going to be more efficient. I've got to do some testing, but that's for me to do later. I just wanted to show you guys these motors are here. They are easy to get to, easily accessible, and you can get them ridiculously cheap. So if you're into this kind of thing and you're not doing this, you should be, because you can go and get in. Even if you were just going to fix them and resell them, there's a lot of money to be made right here in this little pile. I can turn $17 theoretically into $2,000 with a little bit of soldering and a little bit of parts, you know, and a little bit of money in parts and a little bit of time. You can theoretically say $100 you put into these motors, you can get $2,000 for resale on eBay. So just wanted to share that. If you like this information, like my video, don't forget to subscribe. I hope this helped, and I hope this, you know, got somebody interested in this topic to make them want to look into this more, because we need more people looking into this kind of thing. And I feel like the more private research we have, the more better off we'll be. So I hope this inspired somebody to go get one of these motors and just play with it. Just take it home, play with it, make it run, put a controller on it, make it run, fix the controller, make it run, and just do testing. And that's where the real learning happens. When you put power to something and you figure out what it does, that's when you learn something. Or whenever you build a windmill blade and you put it out in the weather and you figure out what it puts out and how it works and everything, that's when the learning happens, guys. You can watch YouTube videos all day long, don't get me wrong, I love YouTube. I've learned so much from YouTube. But get out there, get your motor, get your hands dirty, and just have fun, man. This is a lot of fun for me. I love doing this, and just the fact that I was able to get all these so cheap is really exciting, and I can't wait to play. So more to come on these, but anyway, thanks for watching. Don't forget to like, subscribe, and have a good day. Peace.